So very good morning to all of you. So probably those who were not present in the last class, for them, I would like to tell that the YouTube channel that I have said, I have uploaded the lectures. Just go through the initial, just listen the initial lecture just before this, where I have intuitively discussed the limitation of hill climbing algorithm and how that limitation can be overcome with the help of simulated annealing. Now the basic idea of simulated annealing I have taken, and I have said that it is a very effective algorithm in complex problem solving with the help of local search. Again, you can remember that how we are here, because in the class I told that connecting the dots is basically the best way of learning. So we were initially started with AI, then we came to understand about AI agents. Then we learned that AI interacts with the environment to solve some problems. Now environment means where AI actually search for the solution. So that actually consists of search space. Now AI search in the search space for what? For the solution. Now this searching may be informed or uninformed. So in the under uninformed search techniques we have learned about breadth first search, depth first search, then depth limited search with iterative deepening, and then we came under heuristic search or informed search. There we learned the meaning of heuristic, how the heuristics can be beneficial in searching bigger search space for complex problems. Then we learned few techniques of heuristic searches. Yes. Then we have learned about A star algorithm, but before that we have learned about basic heuristics with the help of 8 puzzle problem. We took that how heuristic can be beneficial for solving 8 puzzle problems. Then we learned about their Manhattan heuristics and other heuristics. Okay. After that A star algorithm, we found at the same time we were also learning about greedy strategy. Okay. Now there we came to know that hill climbing is some modification over the normal greedy. Then we have learned about hill climbing algorithms. Once we have learned, once we have got the conceptual idea, then we came to know that hill climbing algorithm may have 3 major problems: the local optima, then plateau, and a ridge. So these 3 problems actually restrict you from getting the optimum solution. And before that, before the start of this hill climbing, we have learned about local searching, and we took the analogy how or why the local search is important. Got my point? Then under local search, whenever we learned about hill climbing, then to talk about the limitations of hill climbing, we tried to find some modifications with the same analogy of hill climbing. That was the simulated annealing. So this is where we are from the initial days of the discussion. So once you will be able to connect all these sessions, all these topics, the idea will be holistic. So that I always suggest to do. Okay. Now how the simulated annealing, actually annealing is a concept of metallurgy, as I told you, and those concepts, that particular concept is simulated in our problem solving for AI agents. Okay, so what is annealing that I have discussed? Can anyone tell me in metallurgy what is annealing? Okay, anyone else? What is annealing?
So to give it a shape, first we have to heat the metal, and then we will just put it in a strip in which we want the metal to be in the shape, and then we let it cool down and take the shape of that scrap. slowly in order to not prevent any type of cracks or other type of fault in the metal. While
Good. Anyone else would like to add something? So one thing you could have understand that it is all about metal. Rather, where we try to do what? We just melt a metal, then gradually cool it. For what? Why? To give it a proper shape. So it's a very simple. So it is a why we have to melt a metal giving more heat or giving heat, sufficient heat such that it melts down. Why? Because we know that the energy of the particles in a metal is higher when it is in a liquid state. Liquid state means higher energy state. Okay, we are not considering the gaseous state because that is also the highest energy state, maybe beyond that also plasma state. I am not going to that, but we are considering here comparing between the solid and the liquid. So in comparison to solid, when a metal is in liquid state, it is having a higher energy inside it, and due to that energy, particle moves frequently. Particles are having in a higher energy state, so for that purpose what it happens, it can move, okay, and that movement can be used for giving it a shape, desired shape. But obviously our target is to solid state metal, not the liquid state. So for that what we need to do, we need to gradually cool it down. Here the term gradually is very important. That also I have discussed. Why gradually? Why not sudden? Because why?
cooling down from a high temperature could break down the metal.
Yes, it can either break down the metal or it cannot give it a proper shape. So the proper desired shape will not be achieved if I cool the metal rapidly or suddenly, something like that. So gradual cooling is important for giving it a shape. So this was actually the basic primary preliminary concept of annealing in metallurgy. Now this is not our concern. Our concern is how that concept is being simulated in our local search. Because once we can simulate it in a local search, it can be given to an AI agent which will be solving our real life problems with the help of that algorithm. So this is a simple concept. Okay, so here now there are a lot of terms which we have learned when we discuss about the actual annealing process in metallurgy. What are those terms? So let us note down those terms one by one, because when we simulate, we have to give a proper meaning of those terms for our program also, for our design algorithms, for our problems. So first term that we have learned was the energy. This term is used in metallurgy. I have used high energy, low energy. Okay. Another that is important, that was what? Temperature. Because higher energy will be achieved with the help of higher temperature. Okay. Then 3, cooling, isn't it? Cooling rate. So why I am talking about rate? Because how fast I will cool the metal down. So these terms are highly related to our metallurgy, but these terms, terminologies are not directly related to our problem solving, because here what we know, here the problem will be given to you in the form of a search tree or a search graph. Okay, from there you have to go for the solution. So how these terminologies can be simulated to our local search. That is to be learned. Clear? Okay. Now I will discuss all these things, but the physical process and algorithmic analogy, let us discuss side by side. So physical process, that heat of metal. So high temperature allows atoms to move freely, already I have discussed. Now what do we mean by, in our algorithm, what do we mean by high temperature? Just recollect. I think after so many discussion, now the hill climbing strategy is clear to all of you. So whenever the temperature is high, that means energy is high. So try to recollect the energy. So whenever the climber having a higher energy, it has the energy to explode. Explode means what? Explode means I will always take the good solution, but for exploration purpose, sometime I will also select worst solution or the bad solutions. Why? Because until and unless I select bad solution, there is a chance that I will be limited to a particular region of a whole search space, which will result into local optima. But my target here is to reach the global optima, near base solution. Now to get the near base solution, I have to explode. So high temperature means accept many bad moves. Okay. So when I am in the high temperature, means when I am in the higher energy state. Okay. Now cool slowly. In metallurgy, it means gradual cooling lets atom settle into optimal positions. Okay? Agree? Now cooling schedule here in our algorithm gradually reduce acceptance probability. What is the acceptance probability? I will discuss. But why probability coming? Because see, whenever I will have a bad move, should I always accept it or not? So because if I always accept it, the bad solution, my overall goal that the climbing the hill will not be achieved. So I cannot accept the bad solution always. Then should I always accept the good solution? So if I always accept the good solution, then my exploration will not take place. So sometimes I have to accept good solution and sometimes I will have to accept the bad solution. But mathematically, how should I decide this? This should not be like my random process or something like that, because whenever I will be writing an algorithm, I have to give it a proper instruction that based on what you will decide whether to select a bad move or not to select a bad move. Now to decide this thing, we generally calculate a probability. Why probability is calculated? Just to decide whenever I am getting a bad move, how often I will select it. So if I get 10 bad moves, if I select 3 among them or 3 times, so 10 times, in 10 occasions, if I get bad move, so among those 10 occasions, if I select the 3 occasions only, then my probability of selecting the bad moves is 0.3. Am I clear or not? Anyone is having doubt or not? If I have encountered 10 bad moves 10 times in my path, so one thing you have understood, that I should not take 10 times. So if I always take the bad moves, then I may end up in downhill, not to the uphill. And if I always take the good moves, I do not take any bad moves, then again the problem will be local optima, exploration will not happen. So I have to do it now. So I have to do some analysis, or I have to do a proper guideline. So for that, a probability is calculated. Based on that probability, I will decide, or the agent will decide, how often the bad moves are going to be selected. Am I clear? The idea or the probability, why probability is required, this concept is clear or not? Because once you do not understand this, the calculation will be irrelevant. Why probability is required? Clear? Any doubt? If you have any doubt, you can ask me. I can elaborate it. Probability क्या है? What is the measure? What is probability? Why we measure probability of something? Not generally. You know, in real life, where you use probability? Can you give two or three examples? Ludo Chakata, you do not use probability, but there is a probability. Card games. All the things you are giving example where there is a probability. I am asking where you use probability to take decision. Take a decision.
When we have many options in front of us, but we have to choose the most appropriate one.
Yes, when you have many options, and from those options you have to select one or two. Then directly or indirectly you calculate probability. Am I clear or not? Suppose there are 3 boxes. This type of mathematical problem you have done it. Okay. Now in one box, you know, there are suppose 5 red balls, 5 black balls. For example, in the second box, suppose there are 5 red balls, suppose 3 red balls, 7 black balls. And the third box is, you know, there are 2, suppose 1 red ball and 9 black balls. Now, if I ask you that you can put your hand in any of the boxes, but your goal will be to give me a black ball. So in which box you will put your hand? The last box where there are only 1 red ball and 9 black balls, because you know the chance of getting black ball is higher there. Why you are not putting your hand there? Though you are not mathematically calculating, but in your mind that probability is because there are more number of black balls, so chance of getting black ball is higher. So that mathematical calculation is there. Okay. So again here I have 2 options. Either to select better move or to select worse move. So whenever earlier in hill climbing, what was happening? Whenever I was getting a better move, I was selecting it. There was no confusion with that. But whenever I got a worse move, I was not selecting it. I didn't select any of the worse move earlier. But here, one thing is unchanged. If I get a better move, I will select without any problem. But if I get a worse move, then also I will select, but with a probability. Not always. With a probability. Are you clear? The difference between here? Okay. Now, result for the physical process, we get a strong, low energy crystalline structure. That's the proper shape of metal. And algorithmic, low temperature means gradually target is low temperature, mostly accept good moves. So whenever temperature will be lower, so this analogy I am not repeating, I have already discussed in my previous class. Okay. Now another thing came here, that is probability of selecting what? Worse moves. So if I can understand, or I can understand the relation between these four terminologies, then we can implement the algorithm. So I think those who have little bit logical mind, they can easily now understand what my algorithm will be, how it can be. How it can be? Can you generalize the steps? It should not be accurate. I'm not taking the need not to be accurate कि accurate ही होना है. लेकिन आप बताओ कुछ steps बताओ इस algorithm जो हम करना चाह रहे हैं. What I am intending to do. Make it more formal. You are making it general but formal in terms of algorithm. Like, first of all, I have to evaluate my current state. Basic thing, current state. I have to evaluate it. What is evaluation? Evaluation means how promising it is. So suppose for hill climbing, those who are actually climbing the hill, for the evaluate means will be the distance from the ground. That is my current. So first of all, I will do what? I will evaluate my current state. Okay. Then what I will do? Then from here I will explore my neighbors. Are you clear or not? I will explore my neighbor. Now this neighbor exploration can be shorter, nearer, or it can also be far. এগুলো আমি আগেও বলেছি. So if for each and every neighbor I will eval my next state, eval n1, eval n2, eval n3. Now if my eval n is greater than eval c for climbing. So climbing means this is my maximization problem, isn't it? I would like to maximize my height. So again I am repeating, though I have already repeated earlier, that minimization problem is also same. There I will check whether eval n is less than eval c or not for minimization. For maximization we are checking eval n is greater than eval c. Okay, same, no problem is there. Okay, so if it is, then now for our example or analysis here in this class today, we will consider we are in a maximization problem. So we are climbing the hill, so our height should be maximized. So what will happen if my eval n is greater than eval c? What I will do?
I will move to eval n.
So I will move from c to n, because it is whenever I will get a better solution I will move. Is it clear or not? So accept n, else mean what? Else if এর দরকার নেই. Else means in the else case what will happen? Eval n will be less than eval c. So whenever I am talking about else means actually I am considering eval n to be less than eval c. So in that case, here actually how it differs. Here in earlier cases we are directly rejecting it, but now what we are doing, we are accepting it with accept n with probability p. Got my point? So this is actually the core of this simulated annealing. Am I clear? So now the question comes, so energy that I was talking about. So can anyone guess that how energy can be represented in our climbing, hill climbing, or in our problem algorithm? How? Any guess? I think if you think, you can answer. The result of energy is that how many chance you will get. But what should be the energy? How I will measure my energy? Consider in terms of climbing, means whenever in a low, your energy is high. Whenever you are higher altitude, your energy is low generally. See, every time, at every step, you will have a particular energy. Yes or no? So, as higher altitude, whenever you are going, actually you should have a low energy. At the initial, you should have a high energy. Now, whenever your next state, try to understand, where you will have to put more energy. Suppose I am here from, suppose my initial eval C was, eval C is 10 and eval N is suppose 12. This is one scenario, and eval C is suppose 10 and eval N is suppose 25. Now you consider where the energy difference is high. First case or second case? Second case. Because here a lot of energy has to be compromised to make the change, make the move. Are you agree with me or not? You are in the 10 feet. Here there is a 12 feet. Another 20 feet. So where do you recover more energy? Energy difference? यहाँ से यहाँ, more or less. I am not talking it frequently. I am talking about difference because it will vary from problem to problem. Are you getting? But the energy difference is high whenever the difference between my current state and the next state, the neighbor state, is high. Okay, so this difference, so in our algorithm we use the energy term delta of E. So delta means, you know, delta is used for small change or a difference. So it will be symbolized by my eval C minus eval N. So this is my energy difference. Eval C means current state का जो मेरा desired value of fitness value बोलो, optimization value बोलो, जो भी बोलो. So for here it is my height, and this is next. So now you tell, when this delta E will be higher towards the ground or towards the peak? Towards the Y. Towards the ground, you are absolutely correct. Why? Exactly. Exactly. Very good. I'm happy that you are understanding. So when towards the ground, you have a more chance to explore. Means bigger jump. So bigger jump means bigger difference. Okay. So the probability of selecting the worst steps will be high, should be high when this daily is higher. Yes or no? Okay. But here uh, in metallurgy, the cooling this probability is considered to be with the help of a Boltzmann constant. That is a complex equation. I'm not going to that. I'm considering a simplified version. The simplified version is saying that if this is the case, then select the next state, because daily you should always calculate from the starting of the ground selected till you are reaching. Whenever you will be moving, whenever you will change the what state, daily will be calculated, and based upon the daily I have to automate the algorithm. Try to understand, because every time I should not check, the algorithm should work by its own. So the probability should be like that. Whenever daily is higher, assume that you are in a lower part of the hill, and whenever daily is lower, becoming less, that means what? Moving upward. So at that time, the exploration probability should be less. Clear? So it is given in such a way. So probability is given like it is considered to be as a e to the power minus delta E by T. This is the probability based on which the what I consider, based on which I will select the worst move. So obviously you will understand, whenever daily is positive, okay, this p value will be high. When daily will be positive, when, try to remember what was the equation of daily? Eval C minus eval N. So whenever it is, sorry, eval N minus eval C. যেটাই করবে accordingly will decide, no problem. Means my next state is better, so I should use the probability function in such a way that whenever I am getting the better move, I should always select, so probability should be high, and whenever I am getting worse move, there should be a probability. Are you clear or not? So this value here, why I am giving negative, this is a mathematical relation, you can easily understand that probability, to get the probability value higher whenever daily is positive, so you can understand, and whenever daily is negative, it will be lower. I will give you an example so that will make the idea very clear. So what is T? T is here the temperature. Why it is relevant here? Because this ratio will be higher whenever T is low, and this ratio will be lower when T is, sorry, T is more. Are you getting? T কমবে, এনার্জি তো তোমার এখানে চেঞ্জ হবে এইভাবে. So now see, this is the basic concept. Now discuss it more formally. Here the equation that I have written, you can check here. So high temperature means accept most of the moves. That is your exploration. So there I will not much select about better move or worse move. Most of the move I will take just for exploration. Low temperature means accept only good moves. So exploration and exploitation, two terms are there here. Exploration means take almost all moves, and exploitation means take only the good moves. Okay, reject the bad moves and decrease over time. It is decrease over time according to cooling schedule. This cooling schedule is very important. Means how the temperature you will decide. The selecting the value of T is very important. Why? Because T is actually affecting the delta E, the overall value of E to the power minus delta E by T. So indirectly it is also affecting the P. Are you getting it or not? So T value should be, it should get a higher value and gradually it should move towards 0. That is the target. But how? I should abruptly change it. I should linearly change it. I should exponentially change it. I should logarithmically change it. This is where mathematics is coming. Why? I told you na how the mathematics is related. Now you are a designer. No? You are in the responsibility to design the algorithm. You have understood everything. But who will select it for you? It's you. Got my point? So based on the T, because if the T decreases, आपने T का ऐसे function बनाया that T decreases very rapidly. Then in that case, what will happen? In metallurgy, you know what will happen, but here what will happen? You will not be able to explore far. একটা ছোট জায়গাতে বেশি একটু লাফাঝাপা করে থেমে যাবে. Okay, but if you make the T too slow, then it will take a long time to converge to get the solution. So again there is a trade-off. Neither you can cool down too rapidly, nor you can cool down too slowly. So the selection of this T is very important. And in metallurgy, T is a temperature, but for you T is the parameter that you will give a value. From there you will gradually decrease it. Simple. Are you getting it or not? And acceptance probability. So this daily is the change in the objective function. Objective function means fx, which I am going to maximize or minimize. Indirectly, which I am going to optimize. So for minimization problem, my target will be to minimize the fx, and for optimization maximization problem, my target will be to maximize the fx. Simple. And this fx is called the objective function. Okay. So here objective function is what? Height from the sea level. This is your objective function. Simple. Okay. And daily less than 0 always accept. So see, whether it is less than 0 or greater than 0, that depends on the behavior of the problem. So do not consider sir kabhi aap bol rahe ho less than, kabhi aap bol rahe ho greater than. And again it depends how you are writing. Eval C minus eval N or eval N minus eval C. So simple. Accept means better. Okay. And greater means what? Worse. So you can from this here, this what is written here accordingly, if daily is less than 0, what does this mean? Eval, it is actually calculating eval C minus eval N. Is it or not? Then only daily will be less than 0 for the better moves. And when it will be greater than 0? For the worst move. Now, for the worst move, it will accept with probability P. What is that probability? Probability will be calculated like this. What is daily? Daily is the difference between the current objective value and the next objective value, neighbor. What is T? Temperature. Now T should be giving a schedule. Means T should be like that. T should be T minus alpha. Now this is simple linear decrease, but it should not be always like this. Alpha means the very small value that it will decrease after each iteration. It may be 001, 002. If the value of alpha is very high, quick cooling. If the value of alpha is very low, slow cooling. So the value of decision of the alpha is very important. Up to this, it is clear, or you have any doubt? Last bench, I am asking you, are you getting anything? So what is P? Probability of what? Anyone? What is P? Probability. Probability of what? Anyone? Bolo, you can tell. What is P? Probability of selecting the worst move. Probability of selecting the worst move. Because if it is good or better, always select. So there is no probability there. Probability is coming whenever you are getting a worse move. Because you see a better move always accept. And for worse move, accept with probability. Is it clear? Yes or no? So what will be your algorithm? So first you calculate the eval C. Explore the neighbor. Explore the neighbor, and based on a Q or fringe, you know how to explore. Already you have learned it. Now for each neighbor you calculate. For the next local search, you are only calculating next. So if you are getting a better move, make the move. If you are getting a worse move, calculate the P. Based on the P, take the next step. Are you getting or not? So then cool little. After each iteration, there will be small cooling, and again explode. If you are getting a better move, select. If you are getting a worse move, again calculate the probability. Then again cool. So in this way it will continue. Now whenever there is a probability of taking worse move, means what? I am actually exploring the other part of the search space. Am I clear? One example I can show you. So here I will show you this graph later after some time, but before that, local search. No, not one. This one. Okay. See, this is a very interesting example. Now, here there is a problem for the agent. The problem means there is a heat map in the image. Okay. Now, heat map means there are some greenish regions and some blue regions. So try to understand that greenish yellow means higher temperature region, and blue means cool one, cooled. So my agent का target होगा that always try to reach a higher temperature region. Now it can start from any part of this problem. So right now here, if you can see the red dot, can anyone see this red dot? देखते बच्चों? So cool blues means low and warm greens means high. So my target is to green dots accept the moves and blue dots means proposals are rejected by simulated annealing. So there are various different dots. So through this, suppose here it is starting. Now from here actually what is the agent will search, try to search whole space and जो आइडियल एजेंट होगा वो ए या फिर ये तीनों रीजियन में कहीं एक जगह पर उनको रुकना चाहिए बिकॉज दीज आर द मोर वार्मर रीजियन. Are you getting what I'm saying? Now let us select not the hill climbing for as you are learning the simulated annealing. Let us select simulated annealing. Now try to see here. Here I am taking 3 parameters. Any guess what are these parameters? Step, T0 and alpha. T0 means what? Initial temperature. Very good. And alpha means change in temperature. And step means how far it will check, whether nearest closer nodes or farther node. So step ज्यादा मतलब ज्यादा जंप लेगा. Step छोटा मतलब small jumps. Okay. Now let us शुरू में हम क्या करते हैं, दोनों ही चीज देखते हैं. छोटा छोटा स्टेप लेके देखते हैं. एकदम छोटा स्टेप ले लिया. ओके, तो छोटा स्टेप मतलब वेरी नियर देखेगा, ज्यादा दूर नहीं देखेगा. नाउ लेट अस रन दिस. वेयर इज द रेड डॉट? सब देखते बच्चे पुत्ते के लाइट ऑफ कर অফ করে দাও. ওইদিকে আছে মনে. Now everyone can see the red dot. Okay, now let us run it. Can you see the move? Its target is to reach any of the hot region, but unfortunately it is still working. Now see, it has come. Finally it has reached one of the hot region. Are you getting? So here the objective function is the pixel values of yellow is green. Okay, so higher those value means it is moving. This is my higher objective function. Simple. So now it will run further here, few more moves, but it will not move from there because now the term has come to cool down. So और भी छोटा छोटा move लेगा, it will not explore further. So it will reach there. And after some time it will stop. So just we have not much time. Now make the step higher. Okay. Where is the now dot? Dot कहाँ है अभी? दिख रहा है? Now see the jump. Now it has go to the out of the image. Now it will expected to return. Probably it is expected to return after some time. Now see, higher step means one thing you can understand that it is exploring the other region of the image. Huh? ফার্স্ট ইজ মনে হচ্ছে তোমার যেহেতু তোমার স্ট্রাইড গুলো বড় আছে। Okay, got it. So it has now explored the other region, but that does not always mean ki the better one. But it has found one solution because this is also one of our solution, isn't it? Now reset it. If the alpha is very high and initial temperature is low, then there may be a problem, though it is now moving. Now alpha is high means what? Cooling rate is very high. Now the move is, suppose check here, it is little bit random, more random. It is not actually optimizing properly. And one thing also you can understand that it is not giving you the desired solution. Have you seen? Just randomly it is moving and it is also not converging. So the behavior has become random. So alpha should not be too high. Okay, so I will upload this. You can try some other values also. This is a fantastic way to check. Okay, but you know what should be the use case of normal hill climbing? So let us check the hill climbing. Here only the step is there. Same step you check. Now here it is nearer to my desired location, so there is a chance it will give you, but it will take very less step. Just 3 steps it will reach. So let's check another. Now see here the difference. But it is suboptimal solution, you can easily understand. It is not an optimal solution. But all the time we have run simulated annealing, we have found that it has found any of my desired location. None of them has selected that region. Selected, but hill climbing has selected it. So hill climbing may be little faster, but it is not optimum always. Not optimum always. So this is where actually simulated annealing differs. Okay. Okay, now let us go back. So this is a graph. You can see here, for any kind of optimization graph should be what you know, that suppose if the temperature and energy difference are changed, so when the temperature is cooled down, you can see that my graph is being optimized. This is my probability of selecting the worst move, P. Now see here delta E. So as my delta E is minimizing, as I am cooling down, the probability of selecting the worst move is also lower. Are you understanding? So whenever my energy is high, probability will also high. So here that is because if you increase the temperature, see the probability is also increasing. But whenever you lower down the temperature, probability is decreasing. So initially it is high, but gradually it is okay. Now that I was saying, this pattern is very important. This position, it will give you a lot of insights. So cooling means cooling, as I was telling na. So cooling is a very important parameter. T. How you will cool? Many things depends on that. So there are generally many types of cooling function. Linear cooling, that I have already told you, T0 minus alpha T. Okay, T is a constant, alpha is a value which will be tuned. And this is simple but may cool too fast. This type of cooling function. Exponential cooling, that is T0 plus alpha to the power T. It is somehow alpha near about somehow 0.95 के आसपास अगर रखोगे, that is the best value. And cooling will be exponential, curve will be like this. And for linear cooling, curve will be like this. Okay, so this type of curve you can see here. For linear cooling it is blue, so it is almost linear. Can you see this line, blue line? And exponential cooling, see this green line, it is gradually decreasing. And logarithmic cooling, then stable. This is actually required, this difference, stable one. In optimization, your algorithm is working fine. So whenever you will be finding any optimization curve, always notice how your curve looks. If your curves like this, that means optimization is not taking place at all. It is zigzag. Zigzag means my algorithm is not working, or I am not getting my kokhone zyada kokhone kam. Okay, if your algorithm is like this means what? There is a guaranteed local optima situation, because suddenly the value dropped. Okay, and after that suppose it is increasing, but this is the local optima situation. This is your fx if you are trying to minimize. Okay, this is your iterations. And but the best scenario is this type of curve. This is your number of iteration and this is fx. T. So if your curves looks like this, that means you can understand your algorithm works fine. The gradually it is exploring and giving the value. Clear? So आज के दिन के लिए बहुत हो गया. So I am not going to take the numerical examples, but I think you can go through this benefits and challenges, which will make the idea more clear. But before that, I would like to ask you that any doubt what we have discussed so far, that what is simulated annealing and how the concept of metallurgy, the normal annealing is simulated here, how the energy is symbolized here in our algorithm, what is temperature there and what is temperature here, what is the probability, what is the need of the probability. Okay, this probability function is also very important. The probability that I have used now, that is a normal simple probability linear one, but actually people do not use that in simulated annealing. In simulated annealing, suppose if my probability changes abruptly like this, so this is very hard to handle. And one thing is very clear, probability should be always between 0 and 1. Okay, so the function which can give the value beyond 1, so that should not be considered. But here whenever calculating the value, sometime probability value will come beyond 1. So that's why one smart function used, that is called softmax, and its use is like this. The function is like this. Earlier we were using this, but now it is this. Okay. Now the graph of this probability distribution will be like this. So between 0 and 1. So like this also. So it is 0, this portion is 0.5, this portion 1. I will take an example because today I do not have the time. I have made this example we will do in the next class. Here you will find that this graph na probability distribution curve I have given here. How the p value changes with the values of some numerical inputs. We will take eval c, eval n and details में करके देखेंगे कि कैसे change होता है, which will make the idea further clear. So any doubts so far? Is it clear? Hey, বুঝতে পেরেছো তোমরা? আমার তো মুখ দেখে মনে হচ্ছে না। Have some idea, got some idea. If you are asked what is simulated annealing, can you answer in your own language? I am not talking about that. First try to answer the things in your own language. How far you understood? Okay, if those who could not understand because maybe they didn't attend the previous class, so today's class also I will upload and yesterday's class is also there, previous day's class. So check that. Still if you are not able to understand, you can come to me sometime, I will make you understand, but this idea should be clear. Before you proceed or move to somewhere, these things should be clear. Okay, turn off.